Thank you, Magnus. Defeating antibiotic resistance. Well, I guess you have all heard about it, and it was up on the agenda on highest possible level last week when the United Nations dealt with this on their 4th health summit ever. So that says something about the dignity. And the most deadly infectious disease in the world is still 2016 tuberculosis. It still kills 1.5 million people yearly, of which about 1/3 dies of multi-drug resistant TB. And this is based on a bit more than 9 million cases. And all treatments of tuberculosis are based on the characteristic of the bacteria, very lengthy and very demanding. At least 6 months for the simplest version, but up to 3 years for extensively multi-drug resistant TB. And it's said that it takes 15,000 pills to treat a multi-drug resistant TB patient. So I guess you believe me, there is severe side effects. And what we see now is that drug-resistant TB is what is increasing, and it's seen in as much as 20% of the cases in certain areas. CDC in the US has estimated that this threatens to kill 75 million people at a cost of $16 trillion by 2015. So this is clearly an issue, and the most important drug against tuberculosis have for more than 60 years been isoniazid. When you treat tuberculosis with isoniazid on a plate like this, you see that after 3 weeks you have bacteria remaining. And there's the issue comes in. QuretechBio have discovered and developed the first ever characterized virulence blocker directed against tuberculosis. It's a small drug-like molecule with good drug properties that disrupts the defense system of the bacteria. But as you can see here, it does not at all kill the bacteria. But without the defense system, we are all at risk, and so it is with tuberculosis. So when we combine QTB1 with isoniazid, we have full eradication of the bacteria. And that is very promising, we think. What's even cooler is that if we take a TB strain that is resistant to isoniazid, and that you see in the plate down there, you have significantly more bacteria growing. But when we combine it with QTB1, we still eradicate the bacteria completely. We can't detect the bacteria anymore. So this is a breakthrough. And how does this happen? Well, we have to go back to some chemistry, and I think that is very nice because that's where it all starts. Isoniazid, the little molecule to the left, the blue one, is a prodrug that is activated by a bacteria-specific catalase enzyme, CatG, and to form an acyl radical that reacts with nicotinamide to form the blue-red complex that then inhibits the cascade leading to mycolic acids. And mycolic acids are essential for the bacteria. So this is a clever thing. But the bacteria is always just as clever, remember that. So under treatment, the bacteria starts to express this enzyme only stochastically. And there we have what is called persistence. It can withstand the treatment. And mutations in CatG are known to cause resistance to isoniazid. What QTB1 does, among a lot of other things, is that it precludes the selection for inactivation of CatG, and in that way, we restore the sensitivity to isoniazid. So based on this finding, we intend to build a new treatment that has its basis on this well-known strategy. But now we can start to target multi-drug resistant TB. And remember, resistance against other antibiotics have other mode of actions. So this basically turns the clock back. But we can also use it to shorten the treatment time. We have calculations making assumptions that we could get it down to a month. And also prevent the resistance development in that way. And this has the opportunity to make huge savings in the healthcare system. And already by shortening the treatment of drug-susceptible TB to a month would save 75% of the drug cost. Applied on 9 million patients, that's $5 billion. And that's the cheap patients, this drug-susceptible TB. If you have a multi-drug resistant patient, the cost in the US is between $250,000 and $500,000 during your 2 to 3 years, mainly based on hospitalization and isolation needs. So there is clearly an economic opportunity here. And in Europe, we spend around $7 billion yearly on treatment of multi-drug resistant TB. So the next step, well, as I mentioned, QTB1 is a small drug-like molecule. It has good PK properties for oral administration. We are ready to start full validation in a mouse model. And here the Cornell model is the gold standard. It's a lengthy study. It reaches nearly over a year, and that, of course, drives the cost. But together with that, we want to test QTB1 with other drug combinations for other TB drugs. And for this, we would need $400,000. The next step would then be with $2 million to profile QTB1 as a candidate drug, and then follow up that with CNC and a clinical proof of concept in a limited phase 2 study for $6 million. If we then go further to gram-positive pathogens, they are causing a mess in the healthcare setting. Typically, we see resistance against bacteria like MRSA, Vancomycin-resistant enterococcus, that jeopardize surgery, cancer treatments, and care of weak patients. And here we see, I guess you have all seen it in the papers, we see resistance against most bacteria here, or antibiotics, sorry. And for MRSA in the US, with 80,000 cases and 11,000 deaths, the business value is estimated to $1 billion. For Clostridium, 250,000 patients, 14,000 deaths, again with a significant business value. What we have done, we have discovered and developed bactericidal small molecules that are powerful inhibitors of MRSA. And we can see with the MIC values that are quite respectably, goes down to 10 micromolars, but they inhibit growth. And inhibiting growth is not sufficient when it comes to bacteria. So in the Kaling assay, you see that those concentrations are not to think of. But as these compounds are biofilm inhibitors as well, we saw an opportunity to boost the efficacy of other antibiotics. So if you take oxacillin, which you see have absolutely no effect at all on MRSA, combine that at 9 micromolar with one of our compounds here at 25 micromolar, we have full wipeout of the bacteria. We can't even detect it. And you can actually see it here. To the left, we have the control experiment with a lot of bacteria growing, and the other 4 examples are totally clear, not a living bacteria. This is promising. If we go to vancomycin-resistant Faecalis, we can see to the bars to the left that GMP57 at 2.5 micromolar has no effect whatsoever. But what the heck, vancomycin at 4 micrograms per milliliter have just as little effect. When we combine them in the red staple at 4 micromolar, you see we have a reduction of the CFU with about 4 or 5 log units. And this is one portion given to the breathing. Not even at 64 micrograms of vancomycin alone, we see the same effect. So the benefit here is that we can restore susceptibility against well-known antibiotics. And that, in that way, we can target those difficult-to-treat infections. But another advantage is, of course, that it's easy for the physician, and it's easy to introduce in the clinic. When you start on the standard care, you add something, and the drug works. And we expect this to be well received by regulatory bodies and things like the GAIN Act in the US and the EMA Office Fast Track. Also, there is an opportunity for an orphan drug designation for MRSA and VRE. And there is new IP for the combinations. So to summarize, TB, we can restore susceptibility against the isoniazid. We can shorten the treatment of drug-susceptible TB, and we are ready to start the in vivo validation as soon as we can fund the study. For gram-positives, well, new bactericidal small molecules is not a small thing, and the combinations gives a killing combo. And we are gearing up to do validation here. It's a bit easier than in TB. QuretechBio originates from a very fruitful collaboration between researchers at Umeå University, where we have Professor Fredrik Almqvist, that is the chemist behind this, and at researchers from Washington University in St. Louis, USA, where Dr. Christina Stallings is our lead on tuberculosis, and Professor Scott Hultgren is the lead on the gram-positives. So I thank you for your attention.
Thank you, Fritiof. So one question, of course, and this is a naughty one. I mean, is it just because they are bloody toxic?
Well, for the TB case, we have data. No, it's not. It originates from biofilm inhibition, as I mentioned, and we have control experiments for TB, where we have full cell viability at 100 micromolar. Slightly less good values for the gram-positives, but that is not as mature project. And also, we haven't done tox studies yet, but in silico screen, Derek Nexus gives no flags. So we can see that it doesn't affect cells in general.
And what about resistance here? Have you tested that as well? Because, I mean, these could in themselves, do you know whether they induce resistance?
Yep. Of course, that is being studied. And for the TB case, I had a talk with Christina this weekend, actually, and she had been trying to breed on resistance there on subtherapeutic levels for a year. Hasn't been able, but you should to produce resistant strains. But you should never underestimate the bacteria.
We all know that. Any questions from the audience? No, then I have one more for you. Sorry for that. so I think the antibacterial research is an area where there are some examples of companies that have put tons of money into this type of research, and then the authority says, oh, great, thank you, we put that compound on the shelf in case we need something that is not prone to resistance or whatever. So, but with this mechanism, that shouldn't be an issue, is that correct?
That's how we see it, and that's how we hope to get it received by the authorities. And especially, I think, with, well, in TB, it's quite obvious that it's so lengthy. Can you shorten the treatment? Then you make a big earning from the authority from the beginning. And with the gram-positives, you should be able to follow back on that.
And are you financed so you can do what you want to do?
As I clearly announced, I hope we need some funding to kick off these studies for TB. So we could use more money, yes.
Well, you will get the school book. That's what you will get now.